vector group as written on the nameplate is actually Dyn1. So I want to first of all start by saying some safety precaution as regarding this. Transformer test, most especially when you are applying AC voltage, differ from other tests, and you have to be careful, you have to be calm, and you must be somebody who is conversant or familiar with the transformer tests. And one of the safety precaution I want to call our attention to is that make sure that the transformer is free from any external connection from LV and HV. Then ensure that the tests such as insulation resistance test, uh, magnetizing current or open circuit current, insulation resistance test, winding resistance test, or ohmic value test is being conducted, and this ensure that this transformer is free from any problem before applying AC voltage. Also, apply voltage at the high voltage side of the transformer on this particular test, because we'll be measuring voltage across. So make sure you apply your voltage at the high voltage side of the transformer, because it is safer for you. And also ensure the safe voltage is used. Like this one I'm about showing you guys now, I used 415 volts to conduct this test. Also, ensure that the voltage you'll be using is within the voltage level that the meter you'll be using to measure voltage across can measure. Don't use a voltage higher than the voltage than the meter you are holding. So let me start by drawing how things should be. And I usually use 4 cardinal points because that is the guide. Let me move up small. Look at it. This is 4 cardinal points. I have my 12 o'clock here. I have 3 o'clock. I have 6 o'clock. I have 9 o'clock. And since this transformer is Dyn1 vector group as written on the nameplate, and this is what was requested for, so we want to verify it will be like this. The 1 o'clock will come out around somewhere here, which is our U face. So I'll be having something like this, like this. I'll be having something like this. This is a triangle. And sorry, in our proof for the connection, we use U, V, and W as the alphabet, but here we use red, yellow, blue. It's still the same. U is still the same as red, V is still the same as yellow, W is still the same as blue face. And the capital letter represent high voltage side, and the small letter represents low voltage side of the transformer. So here now I have red, I have yellow, and I have blue. And since the transformer is Dyn1, so it will be around here. If you check our 4 cardinal points here, 1 o'clock will be around here. So I'm having it like this. So it means small letter red will be here, yellow, and blue, and our neutral will be around here, start point N. All these measurements we are taking based on the derivation we are about doing now. You do your derivation, then you now know where and where to measure voltage across on your transformer. So look at this. Also, yeah, this one is completed. This one is completed. So let's bring out the first condition that should be met before this transformer will be certified Dyn1 vector group. And for more clarification, let me draw what this one means, because there is something hidden here. It's like this. Look at here. Look at here. I have red, yellow, blue, and neutral. I'm using this as the LV bushing side. LV side. LV side of the transformer. So this is our what? Red phase. This is yellow phase. This is blue phase, and this is neutral. So high voltage side will be like this. 1, 2, 3. This is red. This is yellow, and this is blue in capital letter. Low voltage side in small letter. So high voltage side of the transformer. Transformer. So what is happening here? It means the red bushing is joined with this red low voltage joined with red voltage bushing. You look for a jumper cable to do that. So you will now apply red, yellow, blue phase voltage across this red phase, yellow phase, and blue phase. So face to face, and face to face. So this is 415 volts. Between here to here, also 415 volts. Then between here to here, 415 volts. Also, meaning that red, yellow, yellow, blue, and blue, red. So you apply line 1, line 2, line 3 voltage on the high voltage side of the bushing. Now, you take your measurements after the derivation. So look at here. The first condition, if we measure between here and here, then measure between here and here, we also measure between here and here. See how it goes. First condition, condition 1, condition 1, conditions, and this is 1. You measure between red to neutral plus neutral to blue equal to, then this to this, red to blue. Meaning that the apply voltage red, yellow, blue that you applied, you have connected your small low voltage red bushing to high voltage red bushing. Now you measure voltage between red bushing to neutral of the LV. You record the number. You measure voltage between neutral and blue phase of the bushing, high voltage side. You record it. Then you now measure across blue and red. You record the same value. All this I'm explaining, you'll see it from our readings now. So second condition, for this transformer to be accepted as Dyn1. So look at here, between here up to here, and between here to here, you measure. If you look at them, they should be the same voltage, meaning that B B, which is between here and here, between here and here, BB should give YB. And the third condition here, look at here, between here to here, which is Y bushing to Y bushing, should give less, between here and here, should give less to between here and here, which is BY. BY is still the same as having between here and here greater than between here and here. So let's now look at what we have done and the voltage we have measured, compare with this our derivation, and let's see what we will have. Here now, I measured Rn here. Rn to be 163 volts, 163.7, then plus, what did I measure between neutral and blue phase of the transformer at the high voltage side? NB, can we see? I measured 250, 250.9 volt. Should now give, what did I measure between RB? This is it, 414, 414. Now, the second condition, BB, small letter B, capital letter B. BB, let's check. This is it. I measured 223.8. This is first condition. Condition 2. BB, 223.8 should give YB. 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 Look at it here. YB. YB. 220.4. Then condition 3, meaning that YY, where is our YY measured? 222.6. I measured 222.6 less than, what did I measure across? What did I measure across? BY. 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 Where is it? Small letter B, capital letter Y. This is it. 505.6. 505.6 volts. Now, let us verify on our own. The first condition says that for this transformer to be, let me bring my, to be accepted as Dyn1, our calculator is here. Our calculator is here. Our calculator is here. The first condition says that 163 for this particular transformer, 163.7, and based on the voltage we applied, these are the value we got, plus this is 250.9, 250.9 volts, and here our calculator gave 414.6 volts, and our measured voltage across that gives 414.0. So satisfactory, accepted. Then second condition that should be met says that this must be equal to this. By looking at this, they are almost the same, also accepted. Here also, the third condition says that this 222 value, 222.6 should be less than this 505.6, which prove that also, and we also accepted this satisfactory. Thank you very much for watching. For more questions, over this, you can DM me and I'll explain things to you more as you need it. Thank you. You can private chat me in my message box. And for this particular test and verification, these are some of the safety precautions that should be taken before starting the test. And all other tests on transformers with the safety precaution associated with them, the type of test you are doing. If you have question on that as well, you can DM me and I'll explain things to you better. Thank you very much for watching. I don't know if this is clear. You watch, you digest it. Thank you. Bye for now.